Hey everyone, and welcome. So we're going to be digging into a really cool project from Mr. Wilf's Algebra 2 class. And look, this isn't about just solving some random problem on a worksheet. Nope. Today, you are the architect. You're going to design and build your very own unique parabola from the ground up. This is your personal blueprint for success.
So are you ready to put on that architect's hat? Seriously, let's get into that creative mindset. This isn't about finding a single right answer. It's about you making choices, picking your own points and values, and constructing something that is 100% yours. Think of it as a design challenge.
Your whole mission is broken down into 3 simple phases. First up is the design phase. That's where we lay out the math. Then we build, where we create a visual model of it. And finally, we inspect, where we take a closer look at all its unique properties. We're going to walk through them one by one.
Okay, let's kick things off with phase 1, the blueprint. You know, everything you do from here on out starts right here. The choices you're about to make are going to define the entire structure you're building. This is the absolute mathematical core of your parabola.
So this whole foundation rests on just 4 key steps. First, you'll choose a vertex. Then you'll pick any other point that's going to be on your curve. From there, you'll calculate a super important value we call a, and then finally, you'll put it all together to write the final equation. These are basically the algebraic instructions for your design.
Now, let's talk specs. Your vertex, the main turning point. It's got to have integer coordinates, and they need to be between -10 and 10. After that, you get to choose any other point that's going to lie on your curve. It's the combination of these 2 specific choices that guarantees your parabola will be completely one of a kind.
And here it is, the main tool in your toolkit, the vertex form of a quadratic equation. It is perfect for this job. See how your vertex h, k, and your point x, y just plug right into the formula? Once you pop those in, the only thing left to figure out is a, and that's the magic number that controls which way your parabola opens and just how wide or narrow it's going to be.
Okay, heads up, this is a really key requirement from Mr. Wilf, so listen closely. You can't just write down the final value for a. You absolutely have to show your work. You've got to show the algebra of plugging in your vertex and your point to solve for it. This is a totally non-negotiable part of the blueprint. All right, with all the math done, we can move on to phase 2, visualization. This is the really fun part. It's where your equation stops being just numbers and becomes a concrete visual reality. You finally get to see the curve that you designed.
So, when you create your graph, say in a tool like Desmos, you can't just plot the curve and call it a day. You need to act like a real architect and label 5 critical features of your structure. Clarity here is everything.
Here is your graphing checklist. You've got to clearly label the vertex, the axis of symmetry, which is just that vertical line that perfectly splits your parabola in half, of course your chosen point, the roots, which are the x-intercepts where the curve hits that horizontal axis, and finally the y-intercept where it crosses the vertical axis. Each one of these tells a key part of your parabola story.
And that brings us to the final phase, analysis. You've designed it, you've built it, now it is time to inspect it. This is where you get to explain the specific properties of the awesome parabola you just created.
The first inspection question is all about direction. Remember that a value you worked so hard to calculate? Well, if your a is positive, the parabola opens up, kind of like a cup. If your a is negative, it opens down, like a frown. You'll need to state which one is true for your parabola, and it's all based on your a value.
Next up, you're going to compare your parabola's width to the most basic standard issue parabola out there, y equals x squared. That a value you found, it controls this too. Is your creation a wide, gentle curve, or is it a steep, narrow one? This is really a question of scale and proportion.
Okay, now for a really cool practical application. Imagine for a second that your parabola is the flight path of a ball you just threw. Based on your graph, what's the highest point it reaches? Well, that's your vertex. And where does it hit the ground? That's going to be one of your roots. You're basically translating the features of your graph into a real physical story.
So we've made it through all 3 phases. Now let's just wrap things up with a final submission checklist to make sure your project is 100% ready for delivery.
Here it is, the final rundown of everything you need to turn in. You need your chosen vertex and point, all the algebra for finding a, your final equation in vertex form, that screenshot of your beautiful, fully labeled graph, and finally, your written answers to those 3 analysis questions. Just double-check you have all 5 of those components.
And we'll just end on this thought. You've now seen firsthand how this mathematical curve can model the path of a projectile.
But where else do you see it? I mean, start looking around. Think about the shape of a satellite dish, or the cables on a suspension bridge, or even just the stream of water from a fountain. What else in the world around you follows this same elegant curve?